Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic moment of inertia. Let's go to the numerical. Find the moment of inertia about the centroidal x-x and y-y axis of the angle of section as shown in figure. So here an angle section is given. This consists of two rectangles. Okay, for our convenience, we can take rectangle 1 and rectangle 2. Here we are going to calculate moment of inertia about the centroidal x-x and y-y axis. That is, moment of inertia with respect to x-x and y-y axis passes through the center of gravity of this angle section. So first of all, we have to calculate the center of gravity. Okay, here you can see this is an unsymmetrical section. That is, it's not symmetry about any axis. So we have to calculate both x bar and also y bar. First, I'm going to consider the reference line for y bar and then x bar. We know that the bottommost line, that is the reference line for y bar, the leftmost line, that is the reference line for x bar. Okay, so here we can take the bottommost line, that means this one, that is the reference line for x bar, sorry, y bar. This is reference axis for y bar. The leftmost line, that is the reference axis for x bar. And then this angle section, for our convenience, I am going to split into two rectangles, rectangle 1 and rectangle 2. Here, this rectangle 1 up to this I am going to consider. Okay, like this also we can split the two rectangle. Okay, so here I am splitting the rectangle like this. So the rectangle 1 has 100 mm depth, 20 mm width. This rectangle 2, from here to here 80, when subtracted with this 20, it has the linear dimension. That means 80 minus 20, it has the linear dimension, that is 60 mm. Okay, and then this vertical value, that is 20 mm. Okay, so first I'm going to calculate the center of gravity of this section. Okay, first center of gravity calculation. First for rectangle 1. Okay, first for the segment or rectangle 1. We know that for the first rectangle, A1, that is the multiplication of 100 mm and 20 mm. Okay, so 100 multiplied with 20, that is 2000 mm square. Okay, then x1 and y1, both here we are going to consider. X1, here the distance from the leftmost line, that is reference axis for x bar. Here x1, that is 20 divided by 2. Okay, that is 20 divided by 2. So we will get 10 mm. Then y1. Here, first rectangle, second rectangle, both lies with the reference axis for y bar. So here the y bar, y1, that will be the vertical value, 100 mm divided by 2. So it will be 50 mm. Okay. Then rectangle 2. rectangle 2 or the segment 2. For this, same we have to calculate A2. Here A2, for this 60 multiplied with this 20. So it will be 1200 mm square. Then x2. Here you can see up to this distance, that is 20 mm plus the 60 by 2. Okay, so it will be 20 plus 60 divided by 2. This is 30. 30 plus 20, we will get 50 mm. And y2, this vertical value is 20. So 20 divided by 2, here we will get 10 mm. Okay. So A1, X1, Y1, A2, X2, Y2, we calculated. Now we are going to calculate X bar and Y bar. Okay. First for X bar calculation, we know that X bar equal to A1, X1 plus A2, X2 divided by A1 plus A2. Now we have all the values. Substitute the values. A1, 2000 multiplied with X1, that is 10, plus A2, 1200 mm square, X2, that is 50 mm. The whole divided by A1, 2000 plus A2, 1200. Okay. So from this, we will get X bar value, which is equal to 25 mm. Okay. This is X bar. Same way we have to calculate Y bar. Here you can see Y bar, the formula A1 Y1 plus A2 Y2 whole divided by A1 plus A2. So here, then substitute all the values. A1, 2000 multiplied with Y1, that is 50, plus A2, that is 1200 multiplied with Y2, that is 10. The whole divided by A1, 2000 plus A2, 1200. When you simplify, we will get the Y bar value, which is equal to 35 mm. So here we calculated X bar and also Y bar. Okay. Then we are going to calculate the moment of inertia. First, moment of inertia about centroidal XX axis we are going to calculate. Okay. Moment of inertia about the centroidal axis or centroidal XX axis. Okay, moment of inertia with respect to the XX axis, first we are going to consider. Okay. Here we know that moment of inertia for the whole section with respect to the XX axis passes through the center of gravity. First here you can see X bar is 25. It means that here we know that this is 20. So it is more than that. And 35. That means probably the CG will be here. Okay. The center of gravity of the section. From here 25. From here 35. So the XX axis passes through the center of gravity of the whole section. That will be this one. Do you understand? This is actually the XX axis passes through the center of gravity of the whole section. So now we have to calculate moment of inertia of this angle section with respect to the x-axis axis passes through the center of gravity of the section. That means with respect to this axis, we have to calculate. For that, first we have to calculate moment of inertia of the rectangle 1 with respect to this x-axis axis. Then moment of inertia of the rectangle 2 with respect to the x-axis axis. Then finally we will add. Like that we are going to do. First, we are going to calculate moment of inertia of the rectangle 1 with respect to an axis which passes through its center of gravity and parallel to x-axis axis. Okay, so we are going to calculate moment of inertia of rectangle 1, that is the first rectangle, about an axis passes through its center of gravity. That means through CG1. Okay, here you can see the center of gravity 1. Okay, that means we know that it is x1 10 mm and then y1 50 mm. That means from this side, the center of gravity 50 mm. That means the CG1 will be here. Okay, this is CG1. From here 10, from here 50. So the x-axis axis passes through its center of gravity. That means through this axis. Okay, that we can write IG1 or IG of the rectangle 1, that equal to B d cube divided by 12. Okay, so here B, that is 20, and D, that is 100. So we can write 20 multiplied with 100 cube divided by 12. By the simplification, we got the value 1.667 multiplied with 10 power 6 mm power 4. Okay. Actually, this is the moment of inertia with respect to an axis which passes through its center of gravity. Okay, which passes through its center of gravity. Okay, that means this axis. Okay, this we calculated IG1. Do you understand? Moment of inertia with respect to this axis, that we calculated as IG1. But we need moment of inertia of rectangle 1 with respect to the x-axis axis. For that, we got to use the parallel axis theorem. This moment of inertia of rectangle 1 about an axis passes through its center of gravity. That is this one. But we need with respect to this x-axis axis, these two axes are parallel and this is the distance h1. Here you can see this is the bottommost line, axis for y bar calculation. From here to this axis, xx, that is up to CG, that will be y bar. And this one up to CG1, that will be y1. So this distance h1 will be y1 minus y bar. Okay, to avoid the confusion, I just erase all these lines. See, from the bottommost line to CG, that is y bar. Bottommost line to CG1, that is y1. So the difference between these two, h1, that is y1 minus y bar. Okay, I just erase these lines to avoid the confusion. So this h1, okay, that we can write as the h1, we can write as, okay, that h1 we can write as y bar, the difference y1. Okay, so moment of inertia of rectangle 1 about xx axis. Okay, passes through center of gravity of the whole section, that is CG. Okay, this is through CG1, this is through CG, that equal to, that I'm going to take as IXX due to rectangle 1, that is IG1 plus A1 H1 square. Okay, so here H1, that is Y bar, the difference of Y1, and IG1 we calculated already, that is 1.667 multiplied with 10 power 6 plus A1, that is 2000 multiplied with this difference H1. Otherwise, we can take H1, that is Y bar, the difference Y1. Here Y1 is the larger, that is 50 minus 35. That means we will get 15 mm. Okay, that value will be 15 mm. So 15 square. When you simplify all the values, then we will get IXX1, that equal to 2.117 multiplied with 10 power 6 mm power 4. Okay, this is moment of inertia of rectangle 1 with respect to the xx axis, which passes through the center of gravity of the whole section. Okay, so now we calculated this with respect to, that means for moment of inertia of rectangle 1. Same we have to do the calculation for rectangle 2. Okay, then moment of inertia of the rectangle 2, moment of inertia of rectangle 2 about an axis passes through its center of gravity. That means CG2. Okay, here you can see for this, the center of gravity will be from here 20. Okay, plus this one 30. That means from the first point it will be 50, and then this one that will be 10. So here probably the CG will be there. So moment of inertia with respect to an axis, that means this axis passes through its center of gravity. That one is this axis. Do you understand? That is IG2. Okay, IG for the rectangle 2. Here also the same formula, B d cube divided by 12. But here the B value and D value will vary. Okay, that means here B, that is 60, the depth, that is 20. So 60 multiplied with the 20 cube divided by 12. By simplification, we will get 0.04 into 10 power 6 mm power 4. Okay, this is with respect to this axis. But we need moment of inertia with respect to this axis. Okay, that is moment of inertia of the rectangle 2 about xx axis. That means this axis passes through CG of whole section. Okay, that is, this one is CG. That means this one. Do you understand? This IG2, that is this one. This IG2 value is moment of inertia with respect to this axis. But we need moment of inertia with respect to this axis, xx axis, passes through CG. Do you understand? For that, we can use parallel axis theorem. Here you can see this is the bottommost line. From the bottommost line up to this xx axis, that is y bar. This distance, that is y2. Actually, this is the difference between the two axes, xx, and the axis passes through CG2. That is h2. Here h2 is y bar minus y2. Okay, y bar minus y2. Okay, to avoid the confusion, I just erase all these lines. Okay, here I hope you understand this value, that is h2, that is the difference between y bar and y2. So here, this moment of inertia, I'm going to mention as Ixx of rectangle 2, that is Ig2 equal Ig2 plus A2 H2 square. And then here, H2 is the difference of y bar and y2. So from this, H2, the y bar value 35 minus y2 value 10. Okay. So H2 we will get 25 mm. And Ig2 we calculated. A2 also we calculated. Substitute all the values. Then Ixx2 will be Ig2 0.04 into 10 power 6 plus the value of A2, that is 1200 multiplied with H2, that is 25 square. So when you simplify, we will get Ixx2 that equal to 0.79 multiplied with 10 power 6 mm power 4. Okay. Then moment of inertia of the whole section with respect to the axis, about the axis, that is xx axis. Okay, that is Ixx, that equal to Ixx1 plus Ixx2. So when you add both the values, Ixx that equal to 2.117 multiplied with the 10 power 6 plus this value 0.79 multiplied with 10 power 6. Finally, we will get the value Ixx that equal to 2.907 multiplied with the 10 power 6 mm power 4. Okay. Same way, we have to calculate moment of inertia of the whole section about the centroidal YY axis. Okay. Moment of inertia about the centroidal YY axis. Okay, centroidal YY axis. So here also, first we have to take the moment of inertia of the first rectangle with respect to the axis passes through its center of gravity. Then moment of inertia with respect to the axis YY passes through the center of gravity of the whole section. Here you can see this is center of gravity. So this will be the YY axis passes through the center of gravity of the whole section. Okay, this is YY axis passes through the center of gravity of the whole section. Here, we are going to calculate moment of inertia of the whole section with respect to the y axis passes through the centroid. That's called centroidal y axis. Okay. First, moment of inertia with respect to, or moment of inertia of rectangle 1 about an axis passes through its center of gravity, CG, that is CG1, and parallel to YY axis. Previous one is parallel to XX. Now this one is parallel to YY axis. Here you can see this is CG1. Okay, this is CG1. And moment of inertia of the first rectangle with respect to an axis that passes through its center of gravity, that is CG1, and that should be parallel to the YY axis. Okay, that is with respect to this axis. That I am going to write as IG1. Okay, that equal to IG1. IG of the first rectangle. Here, this is with respect to y axis. So, dB cube divided by 12. So, for the first rectangle, we know that depth, that is 100 mm, and B, that is 20. So, this will be 100 multiplied with 20 cube divided by 12. When you simplify, we will get 0.067 multiplied with 10 power 6 mm power 4. Okay. Then moment of inertia with respect to, that means moment of inertia of rectangle 1 about XX axis, which passes through the center of gravity of whole section. For that means whole section means through CG. For that, we can use the parallel axis theorem. As per the parallel axis theorem, here IYY1, okay, IYY with respect to the rectangle 1, that is IG1 plus A1 H1 square. Here this H1 is different from the previous one. Actually, here H1 is the perpendicular distance between these two parallel axes. Here this is H1. Here we know that this is the reference axis, the leftmost line. From here to here, that is X bar. From here to here, that is X1. So this distance H1 will be X bar, the difference X1. Okay. So to avoid the confusion, I'm going to erase all these extra lines. Okay. I'm going to erase all these extra lines. And then here we know that H1 equal to X bar, the difference X1. Here X bar, the value we calculated, that is 25, and then the X1, that is 10 mm. 25 minus 10. So we will get H1, that is 15 mm. And then IG1 we calculated. A1 also we know. So substitute all the values here. Okay. Then we can get the value of IYY1. Okay. IYY1, moment of inertia of the first rectangle about an YY axis. This is not XX. YY axis passes through CG of the whole section. Okay, that equal to IG1. Here IG1 0.067 multiplied with 10 power 6 plus A1 that we calculated 2000 multiplied with H1 that is 15 square. When you simplify, we will get IYY1 that equal to 0.517 multiplied with 10 power 6 mm power 4. Okay. So we calculated IYY1. Next, we are going to consider the moment of inertia of the rectangle 2. Okay. Moment of inertia of rectangle 2 about an axis passes through its center of gravity. Okay, its center of gravity that is CG2 and parallel to YY axis. That should be parallel to YY axis. Okay, so here that axis will be this one. Okay, here you can see this is CG2. So moment of inertia of the rectangle 2 about an axis, that is this axis, passes through its center of gravity CG2 and that is parallel to the YY axis which passes through the CG of whole section. Okay, this one that equal to IG2. Okay, the same formula IG2, same formula dB cube divided by 12. But for that, the depth is 20, breadth or width that is 60. So 20 multiplied with 60 cube divided by 12. By simplification, we will get 0.36 multiplied with the 10 power 6 mm power 4. Then moment of inertia of the rectangle 2 about this YY axis, okay, passes through the CG of whole section. Okay, of whole section. That is through CG. That we can use the parallel axis theorem. Here you can see from this to YY axis, that is X bar. From this to this axis, that means this axis, that is X2. The difference between these two, that is this one. That means we can take H2 equal X bar, the difference X2. Okay. To avoid this confusion, I'm going to erase the extra lines or extra mark in the diagram. Okay. So first the parallel axis theorem. That means IG2 that I'm going to mention here. Okay. So IYY2 that equal to IG2 plus A2 H2 square. Here H2 is the difference of X bar and X2. Okay. The difference between X bar and X2, that is 50 minus 25, that equal to 25 mm. Okay. Now substitute all the values here. IG2, we calculated 0.36 multiplied with 10 power 6 and A2 value. Okay. The A2 value is we calculated 1200. H2 is 25 square. So by simplification, we will get IYY2 that equal to 1.11 into 10 power 6 mm power 4. Okay. So now finally, moment of inertia of the whole section about the centroidal axis or centroidal YY axis, that we can say IYY equal IYY1 plus IYY2. Okay. So here when you substitute the values, whatever we calculated here, IYY1 0.517 multiplied with 10 power 6 plus IYY2, that is we calculated here 1.11 into 10 power 6. When you add, we got the value IYY that equal to 1.627 multiplied with the 10 power 6 mm power 4. So this is the moment of inertia of the whole section about the centroidal axis YY. Okay. So now both the values we calculated. Moment of inertia about the centroidal XX and YY axis of the angle section. Okay. I hope you all understand this numerical, whatever discussed in this video. Don't forget to subscribe my YouTube channel, Vishwaguru, a problem solver, for more number of videos. Okay. Thank you guys. Thanks for watching.